Hey folks, welcome to the breakout room session led by Tony and Greg on cross-region AI model deployment for resiliency and compliance. Without further ado, I'll give it up to them.
Hi, everyone. Thanks for coming. I'm Tony Farias,
And I'm Greg Wood.
and this is our talk on AI across your regions, best optimized for where your users are, for compliance, for resiliency purposes. So first, let's talk a little bit, Greg, about why this talk is important and why you should set up your organization this way.
Yeah, thanks, Tony. Here's the obligatory forward-looking statement. If you've seen any Databricks presentations, you've probably seen this a bunch of time. I don't think it really applies to us, so I'll just keep going. And so what are we going to talk about today? First, a little bit about what does resiliency and redundancy really mean for AI models? Why would you want to do it? Probably you all sort of have a reason for being here, so you might understand all these things already, but good to set some context. Then we'll talk about what does it look like on Databricks to set up those models, to do geodistribution, to do resiliency, and we'll do a little example and demo of something that we set up using Azure, Databricks, and some other components. We'll talk through what those are, and then we'll wrap up with some takeaways and such. So first off, what does resiliency and redundancy really mean for AI models on Databricks and AI models in general? First off, there are a growing number of reasons. It seems like new reasons every single day why you'd want to think about, hey, I've got a model in this region. It's running great. Why do I need to think about something else? First off, there's always new GPU models, new GPU VMs coming out. Some of them are going to be available only in certain regions. Some are only available in certain clouds, right? If you want the latest NVIDIA chips, you may need to use certain regions or clouds to get those. And having an edge on those things can actually make a big impact, both on the model, on the business outcomes of those models that are being driven, and all sorts of other things. So, latest and greatest SKUs on the clouds, certainly one reason. Residency and compliance, right? We hear about this all the time. As sort of Databricks employees, we're trying to solution this kind of thing. And this is, again, one of those things where it seems like every month, every year, certainly, there's a new compliance depending on where you are. And so being able to direct your users to the right model in the right region, not only is that going to improve their sort of results of the model, but it might mean the difference between getting hit with a fine or not, right? If you direct a UK user to a US model and you end up having some breach of data, that's not a good thing. So regulatory compliance, data residency, huge concern. User experience, again, being able to get to the model that's closest to you is going to drive the best user experience. If I'm sitting here in the West and I end up trying to access a model in Australia, it's probably not going to be as good as if I just hit something that's down the street in San Francisco. And then finally, coming out more and more flexibility and lock-in. It'd be really nice if I was able to deploy to not only multiple regions, but even multiple clouds. So, if tomorrow Azure gets really expensive for some GPU or in some region, I can switch to AWS, I can switch to GCP, or some other cloud that might come out tomorrow, right? So having the flexibility and not getting locked into a single cloud or a single region can be really impactful and just gives you peace of mind as you're developing these systems and integrating them into your business. So if this hasn't happened to you, you're really lucky. There's a ton of outages, a ton of new things happening that are really difficult to deal with, right? Even just this morning, there was a big ChatGPT and OpenAI outage, right? So being able to account for these things ahead of time, again, I'm sure everybody in this room has dealt with this at some point, but just to say, you don't know what's coming in the future. So if this hasn't happened to you yet, it's probably going to happen to you like 10 times in the next month. So hope none of that happens, but if it does, we're here to help. So what does geodistribution and resiliency look like sort of at a very high level on the cloud and on Databricks, right? So first off, having a central repository, definitely key. having a single place to deploy from and a single source of truth for your code and your models is super important. Deploying that into your code and IDE environment and having the data there to sort of train those models and get them deployed, also super important. And then having some kind of catalog or registry for those models that you can then deploy a serving endpoint to. Again, sort of need to have that parallel infrastructure in both regions. In this case, could be multiple clouds. And finally, the user piece, having a endpoint where I'm a user, I just want to go to that endpoint. I don't want to point to east, I don't want to point to west. Just give me an endpoint. I want to hit that, and I want to be directed to the right place. So yeah, this all sounds great. Unfortunately, it is a little bit difficult. And there are some, if you've tried to build this out, you probably have dealt with all this yourself. First off, having that centralized deployment isn't always the most straightforward thing. I'd say that's maybe the most straightforward piece on this slide, but it's not always easy in itself. Data, again, is maybe always the biggest challenge. Moving data is slow, and deploying it to multiple places at the same time is expensive. So having feeds into each region separately basically costs twice as much, not just from the storage point, but also from the processing point. And then, if you have differences between those two data, you're going to have differences between your models. So if, region B is a day behind region A, your model might be different between those two, which again, user experience, not great, and all kinds of other things that come with data drift. Governance, having the serving endpoints, being able to serve to the right people, if there's classified data, if there's regulated data in those models and those endpoints, having governance on those is super important, as everybody knows, getting more important by the day. And finally, again, enforcing that the right people go to the right place from the load balancer, from the front end perspective, gets pretty difficult too, as you're building this out yourself. So how do we build this on Databricks? We obviously are a bit opinionated, but we think that there's some really good pieces that Databricks has built out to deal with some of these challenges, and Tony's going to walk through what those look like.
Thanks, Greg. Yeah, so part of the reason for this talk is now is a really good time to be thinking about implementing these, not just because of the challenges mentioned, the rapidly evolving landscape, but because Databricks has come out with a number of tools out of the box that will help you solve this problem. So our goal is to show you an opinionated architecture that you could bring into your organization today. I'll list out some of the tools, and then we'll go and show what those look like in practice. First, we have the fact that Databricks workspaces and code have Git repos built into the Databricks interface in workbooks, in collaborative notebooks, so that you can solve at the source layer for your code being available across environments. Then at the model layer, we have the combination of Unity Catalog and MLflow 3. That'll allow, within a region, your models to be centrally registered, discoverable, permissioned. And with the addition of MLflow 3, we have native model CI/CD deployment capabilities, where whenever something changes with a model, you can start a workflow, a Databricks job, that can then handle deployment across regions or across crowds, as well as validation of your model. AI Gateway is another feature that helps with tracking which request went where. So we do that through inference tables. Every request made of a model is logged within its table in the region. We can also have controls around performance and rate limiting at the level of each endpoint. And then also endpoint level controls. We have model serving, which is scalable, serverless per region, so saving you costs by being able to scale down or up when according to demand. And also, we have our agent framework, which we'll talk about the special case of deploying agents across regions as well. And then finally, we combine that with a single endpoint, single point of contact, and we can build a number of rules using a cloud CDN. So we'll show that. So solving for some of the challenges that Greg mentioned, we have controls at the workspace code level, controls for sharing at the model level, and controls for sharing at the endpoint level. We'll talk about some of these slides when we go through the demo. So here's the architecture of the demo we'll be showing. For the purposes of the demo, we'll only show 2 regions. But know this is extensible across a variety of different regions. And so we'll start with central US as the source of where I'm registering a model. Let's start with a very simple model. So without diving too much into the model being trained, simple sklearn model. But the key point I want to show is, given MLflow 3 capabilities, we can specify where we save this model in Unity Catalog, and we register that to a particular Unity Catalog location. In MLflow 3, models are native objects. The MLflow 3 interface is a lot more model-centric. So whenever you save a model, it's now registered in Unity Catalog. You'll see here, I ran that code, it registered here in the central US environment. You can see that up top here. And I have a version of the code of the model that's been registered. I can see the endpoint, active endpoint, where it's been registered, deployed to. So deployment as here in a particular URL. So this is region specific. This is serving in a central US endpoint. I've also set up a inference table where any request that comes to this central US region will log to this inference table. I can see the model name being served here, and I can see latency characteristics that have been sent to this endpoint here. So how do we do cross-region deployment? Well, MLflow 3 provides this deployment job functionality. So if we see what a deployment job looks like, it links, you can set a number of different tasks. These could be validation of the notebook, of the particular model, so does it conform to certain performance characteristics, and also deployment to different regions. Let's have a look at the deployment task notebook. Go through here. Okay, so here we're using API to deploy in our native region, central US, where it's running. But then we can also leverage model sharing capabilities of Delta sharing to copy the model over to another region. So I'm going to copy it to UK South region here, and you can do this per region. And then I can also deploy remotely from central US using the UK South URL, and then whatever authentication method I choose, to then set this up in UK South region. So every time that I make a change to this model, it will register, it will kick off the deployment job for the model and rerun that task. So the latest version of the model is passed through to the UK South region, and I could have it with multiple regions as well. Now, this is that was a simple GenAI model. Some of you might be deploying agents and might be looking at agent deploy. Agent deploy has a few key characteristics on what it deploys for you. it creates model serving endpoints for your agents. There could be multiple LLMs registered to that single agent endpoint. It'll provision some short-lived service principal credentials, so allowing you pass through authentication from your model to your tools. That's going to be important if you're calling different agent tools and giving you those same credentials that you've set up in one region to the other. It'll enable inference tables if you tell it to. It'll give you live monitoring metrics of the agent, so agent deploy doesn't just deploy a single model endpoint for servicing the request, but also a feedback model endpoint for monitoring of that quality of that agent. And then finally, any metrics around that agent are also deployed as part of agents.deploy. So agents.deploy will be luckily works in a very similar interface. Let's pull that up so we can look at it. Okay, so I've created a separate GenAI model here. So we have a agent being deployed. I can register a number of tools in Unity Catalog tools, and that copying must be registered separately, but thanks to capabilities like Git, your functions you define in one region, you can then run that same notebook in another region to define all of your UC tools. And so I have an agent here that's going to answer questions about Databricks documentation. So it uses a set of tools to answer questions about Databricks documentation. Very similar to the other flow, but instead of just calling to register to a particular endpoint, my deployment job can call agents.deploy in the source region, and then in our deployment task that's registered to this job, we can call agents.deploy. We can do the same set of capabilities here, call agents.deploy in the region we're running from, share the model via Delta sharing, register it in the remote workspace, and then agents.deploy luckily works with setting environment variables as well. So we tested this in Azure workspaces. We tested this cross-cloud as well, Azure to AWS. If you set the Databricks host and the Databricks token, you also have to set an experiment. But you can register it across using one line of code, agents.deploy. You can deploy in your current workspace as well as across region. And so you have model endpoints now across the regions. As mentioned, here's an example of deployed agent with where the requests are taken, but also the feedback model deployed. And it registered in central US and also here in UK South region. So now we have our agent across regions. I'm using VPN here to pretend I'm a user in the UK. And we can use tools like Azure Front Door, which is a CDN that Azure provides, to register both our workspaces into groups. So we have our central UK workspace in a group and our US workspace in a group. We can also have default groups. So here's where you can start to register more and more workspaces for for centralized location. And then Azure Front Door is going to register a number of different rule sets that you can configure. Here we're doing geo-matched rules. So if Azure Front Door URL gets a request from a user in the UK, it'll route to our UK origin group, from the US to our US origin group. And so this way we can, through a single URL, when we call the Azure front door URL, we can register the call, any query passed out to to the relevant endpoint here. So I ask what is ML flow, and we'll receive the result of the agent hitting the UK endpoint, which you'll see gets logged as a table, an entry in the table in the UK, and also all of the performance metrics of that particular call to the UK get registered in the UK workspace. So a setup that uses native Databricks tooling out of the box, using Databricks jobs to register the model across regions. And then here, we use the Cloud CDN to route to the different regions. But each region will keep its set of metrics and its set of questions asked for better compliance across. Being able to see which questions were asked in the UK, which questions were asked in the US, and so on.
I just want to point out, too, part of the whole point of this specific setup was just how simple that is, right? Like, this takes 10 minutes to set up that front door profile. There's a lot more you can do with that, with AWS CloudFront, with GCP's version of CDN. Even out of the box, you get like round-robin, priority-based routing. You get failover from waiting and different things like that. So it is a very simple setup, and that's kind of the point. You can do a lot more. If you need to do things like SQL warehouses behind a front door CDN, you can do that. If you want to add more specific rules, if I have certain VPN gateway CIDRs that I know are within a west, central, and east, I can break those regions down further. But part of the reason here we wanted to show it like this was it's really simple to set up, and it uses pretty much everything out of the box without any custom coding. So just wanted to point that out. These tools are pretty robust, and they can meet a whole bunch of different use cases and different requirements. This one just happens to be something that is really relevant. Data residency and geolocation is super important, and it also happens to be super easy. Okay, so that was our demo. Now, I do, probably pretty obvious, this was pretty manual, a lot of it. It's not necessarily production, but it's not that far to get to production, which is actually pretty cool. And that's part of the great part about using out-of-the-box functionality and these cloud provider tools, right? So if I did want to, say, bring this into a production framework, first off, we talked about centralized deployment a little bit. Definitely would want to bring those code and models and those notebooks that we saw into a centralized place so that if, say, east or central does go down, and now I need to move things to west, it's a lot easier to just switch my front door and then switch my sort of development pipelines over to a functional region. Now, I do want to point out, because I'm a DR guy, this is not really DR. This is resiliency and availability. DR is a whole different thing, but sort of the point of this is not DR. This is really easy, and it's pretty cheap compared to setting up a whole DR system. So just wanted to point that out. Region scale out, another thing, right? Obviously, another great part about this is if I have that front door, that CDN set up, my users don't need to know where they're going necessarily. So if I want to fan out to a whole bunch of more regions, I just add those to my origin group, and that's what I would do, going to production. Dev stage prod, obviously, well-known pattern. Everybody probably knows that. We'd want to do that, bring that into this. Again, very easy to do with those tools that we have within Databricks, because it's all integrated with Git, and it's all integrated with those pipelines that we can set up. Governance and security, right? Again, every company is going to be a little bit different on this. We didn't show things extensively like the AI gateway, like ABAC. That all comes into play here. And then for agents, there's a lot more considerations, which Tony knows a lot better than I do.
Yeah, so tools weren't covered as part of this MVP. You certainly can deploy your UC tools, not via Delta sharing, but you register and run the code across the regions. And you can do that via remote execution as well. Just to point out as well, we used all serverless products here, which is where the governance and security also comes in depending on what your enterprise policies are.
So just to recap this a little bit and some takeaways. First off, business need obviously drives everything. I mentioned DR. That might be necessary. You might need to set up a completely separate region with its own self-functioning processes that don't rely on Delta sharing from another region or that can deploy their full workflows. So first off, before you do anything, figure out what you actually need, figure out your SLAs. If West goes down completely and it's going to be down for a week, then where are you going to be? And what sort of business needs are driven by that?
Yeah, you might have, when it comes to the load balancing aspect as well, maybe it's about compliance across regions, so you need to think about how to set that up strictly. Maybe it's about performance and latency, and Front Door has capabilities on that as well, routing to the lowest latency region.
Yeah. Designing with redundancy, right? I think that's always a good idea, especially in this day and age. A lot of people ask when I talk to them, hey, can I just use a load balancer? Do I really need a CDN? Well, unfortunately, most of the cloud native load balancers are regional. So if your load balancer is regional and your region goes out, it doesn't really help you. So things like that, just things that you need to think about as you're designing these systems. How do I share things across region? Do I need my full data sets in all my regions? Can I just do Delta sharing? These are all things that you need to sort of think about with redundancy in mind.
Further consideration, you have to think about how to validate the performance of your models. Luckily, MLflow 3 provides a lot of those capabilities of being able to see performance per region, and that's all logged out, so you can design logic as to, when you see performance degrade in a certain region, what's going to be the action of your rule set. If you have faulty infrastructure, then you design exception handling to catch that and remove something from rotation. A lot of that built into these native CDNs as well. What we really want to emphasize is we're hoping to package this together and release it out to the wider group. Using as much out-of-the-box tooling is going to mean you don't have to reinvent the wheel. So here we aim really to think about Databricks native components and how you can use that to make this process less painful and design with whatever objectives you have in mind.
Yeah. And again, to emphasize, things like availability, SLAs, DR, all play into this. They're related. Talk to me about that. If you want to talk about DR, I'll talk to you about that for as long as you want. We will put together sort of a blog post on all this, have some source code to share, some Terraform templates, all that kind of stuff, following, once we have some time to put it all together. But, again, this took maybe a day to set up. It's not like it took us weeks and weeks to put together. So it is really designed to be pretty simple and out of the box. Use as much as possible.
All right. Thank you so much. We'll take questions.